Welcome back, deep divers. We're about to plunge headfirst into a question that's been puzzling thinkers for centuries. Is nature, at its core, continuous or discrete?
We've got an excerpt that really throws some fuel on the fire.
Yeah, the author goes after some pretty big targets. Math, physics, even the way we think about numbers.
They definitely don't hold back.
Basically, they're saying that physicists might be trying to understand a continuous universe using math that's inherently discrete. It's kind of like using Legos to build a sandcastle.
It's an interesting analogy.
So let's dive in. The author starts by taking aim at our concept of numbers. They point out that most math deals with these neat, discrete units, 1, 2, 3, easy peasy. But what happens when you're trying to grapple with something massive, something so huge that counting it with regular numbers becomes impossible?
The author uses this really evocative phrase, big symbols. They're talking about numbers so large that they basically become abstract symbols rather than actual quantifiable values.
Yeah, it's hard to even wrap your head around. Do you think you could break that down a little more?
Sure. The author gives this example of a whole galaxy, where every atom, every particle, every speck of dust is replaced by a digit.
Wow.
And even that, they say, doesn't come close to the scale of these big symbols. They even mention Graham's number, which is a number so big that if you tried to picture it in your mind, the information density would create a black hole.
Black hole. Okay, that's next level mind-blowing.
Mm-hmm.
It makes you wonder if our usual ways of thinking about math even apply at that scale.
Exactly. And that leads to the author's next point, which is how these big symbols really mess with our understanding of infinity.
Yeah, infinity is already a pretty slippery concept, even without bringing galaxies full of digits into the picture.
Right. The author says that our usual definition of infinity hinges on this idea of knowing what's finite. Like, we know a day is finite, so we can wrap our minds around the concept of an infinite number of days. But when you're dealing with these big symbols, the concept of finite itself kind of breaks down.
It's like trying to explain forever to a little kid. Their eyes just glaze over.
You got it. And when you can't even grasp how big something is, how can you even start to talk about its opposite, infinity?
So then, the author takes this critique of infinity even further and connects it to the idea of continuity.
And this is where things get really interesting.
All right, it's like, wait a minute, are you telling me that our entire understanding of smooth, unbroken change might be built on a foundation of sand?
Yeah, the author argues that continuity, as it's understood in mathematics, relies on this whole idea of infinitesimals, these infinitely small quantities. But if our concept of infinity is shaky, then infinitesimals are on shaky ground too.
So, like, the whole concept of continuous change, which is central to so much of physics, might be based on a shaky understanding of infinity.
Exactly. And that brings us to the author's main point, which is that physicists might be relying on a mathematical framework that's not quite up to the task of describing a potentially continuous universe.
It's like using a blurry lens to study the stars.
Yeah.
You might see something, but are you really getting the full picture?
Now, to be fair, the author does acknowledge that physicists have made incredible progress using these mathematical tools. But they kind of throw this question out there, is that progress maybe in spite of the underlying math, not because of it?
So what's the takeaway for us non-physicists? Does this mean we should all just throw our hands up in the air and give up on trying to understand the universe?
No, not at all. But it does raise some really profound questions, like if our current understanding of math is fundamentally discrete, does that limit our ability to truly grasp a potentially continuous universe?
Right.
Could there be another way of doing math, a completely different framework that would allow us to see things in a whole new light?
This whole deep dive has really made me question some of my basic assumptions about the universe and how we make sense of it.
Me too.
Yeah.
And it leaves us with this challenge to keep pushing the boundaries of our understanding, to keep questioning, and to maybe even imagine entirely new ways of thinking about math, physics, and the nature of reality itself.
That's a great note to end on. Keep those thought gears turning and let us know what you think. Is nature continuous or discrete? Is our math up to the task of describing it? Could there be a whole new kind of math out there just waiting to be discovered? Until next time, deep divers. Welcome back, everyone. Ready for another deep dive?
Always ready to dive in.
Today, we're tackling a question that has been puzzling physicists and philosophers for ages, literally, like centuries.
Oh yeah, big one.
Is the universe, at its core, like a smooth, unbroken flow, or is it discrete, made up of these tiny, indivisible blocks? And we're exploring this through a fascinating source. Is nature continuous or discrete.txt? And get this, it challenges something we often just take for granted, like as a given.
And what's that?
Math.
Math, huh?
Yeah, math itself. The source argues that math, which, we use as this tool to understand the universe, might actually be inherently, fundamentally discrete.
Interesting. Even though we often think of it as continuous.
Exactly.
Yeah.
Right. And the author is making a pretty bold claim here, suggesting this has massive implications for how we as humans, as physicists, as thinkers, interpret what we observe about the universe.
I see. Yeah, I see.
I mean, think about it. How can we really say anything definitive about whether reality is continuous or discrete when the very math, the very tools we're using might have these built-in limitations?
That's a great point. It's like it's almost like trying to understand the ocean,
Okay.
but only using buckets.
Interesting analogy.
Yeah, you can get a sense of its vastness. You know how big it is.
Right.
But you never truly grasp that fluidity, the interconnectedness of it all.
Yeah. I like that. So you're saying that, we might be missing this whole dimension.
Exactly. And the source is using that kind of analogy to really challenge us, to think critically about the tools that we're using in physics.
Right.
And, to consider the potential biases they might be introducing.
So essentially we're looking at the lens itself, not just what we see through it.
Yeah, exactly.
So all right, the author's saying math, this fundamental thing, might be discrete.
Mm-hmm.
But what's the evidence for that?
Well, they dive into some really interesting, pretty complex territory, actually. They take a close look at these mathematical concepts, number, infinity,
right.
continuity, these cornerstones of math.
Bedrock. Yeah.
Yeah, exactly. But the argument is that these concepts, even though they seem so fundamental to us,
Right.
they start to kind of break down a little bit
Okay.
when we try to apply them at the universe's scale, to those vast scales.
So it's like the scale is almost breaking the math.
In a way, yeah, it's like our tools aren't built for that.
All right, so break it down for me. Let's take these one by one. Let's start with number. What's the issue there?
Okay, so the author's arguing that the concept of number, the way we traditionally understand it, it becomes almost meaningless when we're dealing with these extremely large quantities, these massive numbers.
I see. So like when you get to a certain point, a number is so big, it's hard to even fathom. So how do you even work with that?
Yeah, they use this really striking example.
Okay.
Just imagine you're trying to represent the number of atoms.
Okay.
In the observable universe.
The observable universe. Wow.
Right. As a single written out number.
Whoa, that would be a huge number.
Huge doesn't even begin to describe it. It's mind-boggling, right?
Yeah.
And they're saying even if you could, write a digit on every single atom in the universe, you still wouldn't have enough space to write that number out.
So it's like the number's so big, it's almost like it breaks the universe itself.
Yeah. And so the author's point is that at that scale, number becomes less about something you can actually quantify.
It becomes more of an idea.
Yeah, more of a concept.
It's like the idea of the number, but the number itself is too big to grasp.
Exactly.
Okay, so it's like the number becomes so big, it loses practical meaning.
Precisely. And the author uses this as a jumping off point.
Okay.
To then question the concept of infinity, too.
Okay, all right. So how does number lead to infinity?
Well, they're saying that the way we often define infinity is in relation to finiteness.
Okay, so like the opposite.
Yeah, like infinity is what you get when you just keep counting forever.
Yeah, just never stop.
You just keep going and going and going. But if the concept of number itself, breaks down.
At a certain point, right?
At a certain scale, then what does that even mean for infinity?
Yeah, if the numbers themselves become meaningless, then infinity, which is based on those numbers, also becomes
fairly fuzzy.
It's almost like by defining infinity as just the opposite of finite, we're kind of like crapping it.
Yes.
Within our limited human understanding of numbers.
Exactly. That's the core of the argument.
Okay. I'm following you. So we've got number, which leads to infinity, and now I bet this leads to continuity.
You got it. You're right on track. This leads us directly to the author's critique of continuity.
Okay.
So in math, we often work with this concept of infinitesimals.
Infinitesimals.
Right.
I've heard that before. Refresh my memory.
Right. So they're these infinitely small quantities So small that they're practically zero, but not quite.
Like taking a slice of something and then slicing that slice again and again and again, like infinitely many times.
Exactly.
You're getting it.
But if we're saying infinity is a shaky concept, are these infinitesimals even real?
Well, that's what the author's getting at. They're saying because the concept of infinity itself is kind of on shaky ground, right, based on what we just talked about.
Right.
Then the concept of infinitesimals, well, that gets shaky too.
It's like a house of cards if the bottom falls out.
Yeah. And therefore, the whole idea of mathematical continuity, which relies on these infinitesimals, well, that might be on shaky ground too. So then how do we even describe something as continuous if we can't trust that concept in math?
It's a great question, and it leads to this amazing twist the author throws at us.
I love a good twist.
Yeah.
Lay it on me.
Okay, so they suggest that maybe, just maybe, nature itself, reality, it is actually continuous.
Whoa, okay, so even though our math might be fundamentally limited, maybe the universe itself isn't.
Precisely. It's like this fascinating paradox.
It's like we're trying to fit this round peg, the universe, into a square hole or discrete math.
Such a great analogy, and this leads to such a crucial question, right?
Yeah.
If the universe is truly continuous, how can we, with our potentially discrete math and our finite minds, ever truly grasp it?
Right. It's like if reality is this smooth, unbroken flow, how can we ever fully capture that using tools that might be fundamentally like these chunky separate pieces?
It's a truly humbling thought, and I think it serves as this powerful reminder for us that the way we frame our questions, the tools that we use, and the concepts we rely on, they all have an impact. They all shape the answers that we find.
So what does this all mean? Like for me, for someone who is, just trying to wrap their head around the universe?
I think the key takeaway is awareness, being aware of the potential limitations of our tools, of our concepts, our ways of thinking. We shouldn't just assume that math gives us this perfectly objective view of reality.
It's like a map.
Yeah.
It's useful.
Yeah.
But it's not the actual territory.
Exactly.
We should be open to the possibility that there might be aspects of the universe that are just beyond our current understanding, maybe even beyond our capacity to ever fully grasp.
That's such a profound thought. And it leads to the question, even if we can only perceive reality in these little fragments and these, glimpses, is there still value in trying to understand those fragments the best we can?
And I think, yeah, absolutely. Because even if we can't fully grasp this, the totality of the universe, this journey of exploration and discovery, this trying to figure it out, it leads to incredible insights.
Oh, absolutely.
And a deeper appreciation of just the mystery of it all.
I completely agree. It's the journey, not just the destination.
It's the journey. Well, a lot to think about, that's for sure. Thanks for guiding us through this deep dive. It's been mind-blowing.
My pleasure. Always happy to explore these big questions.
Until next time, keep those brains buzzing.